We get started. So we'll get started. I think we completed the previous chapter, except one topic, that is eddy currents. Eddy currents is theoretical topic. I didn't want to start with that on Monday. So we'll start with a new chapter. Okay. So about eddy current, we'll be learning in this chapter also. There is something called as eddy current loss. So at that point, we'll discuss what exactly eddy current means. So now we'll start with the next chapter, that is alternating. What happened?
Sir, your voice is low, sir.
How is it better? How is it better? Yeah?
Yes, sir.
Okay. So we'll get started with the next chapter, that is alternating current. Okay. So in our third chapter, we discussed a topic called as current electricity. So there also we discussed about current. So here also we are discussing about current. But what is the basic difference between those two currents that we are trying to talk about? So there you spoke about direct current, and here you are going to speak about the current which is changing with respect to time. So if you see in the previous class, the topic with which we entered is called as AC generator. So in an AC generator, what happens? It generates an AC value of how much? Magnitude. If you check your notes, you will have it. That is the last derivation I wrote. So E is equal to E naught sine omega t, where E naught is called as peak value, omega is called as the angular frequency with which the armature coil is revolving, and T is obviously the instant at which the time is being defined. Did you guys write down that point? I would have ended the last session with this equation. E is equal to E naught sine omega t, where E is called as the instantaneous value, E naught is called as the peak value, omega is called as the angular frequency, and T is called as the instant at which the EMF is defined. Right. So having said this, we'll get started with what exactly we are going to deal in this chapter. So if you see, the name of this chapter is alternating current. So what does an alternating current basically mean? So it is that current. Okay, if you're able to define a current whose magnitude and direction. So I'll not say whose magnitude. Yes. Yes, whose magnitude and direction changes with respect to time. So please make a note of it. The alternating current is that current whose magnitude changes continuously with time and direction changes periodically. And direction changes or direction reverses periodically. Direction changes periodically means it will change with respect to the direction reverses periodically. Okay. Then what exactly does a direct current mean? It is that current whose magnitude. So I will not say magnitude whose direction is not changing with respect to time. Okay. Now, if I take a scenario, so what kind of current is this? So this you can call it as alternating. And why did you call it as alternating? Because you're able to see the magnitude and the direction is periodically changing with respect to time. Whereas if I take a current like this, then you call it a direct current because its magnitude and direction are constant. Now, what about me taking a current like this? What can I call this current as? So this current is not called alternating. It is also called as direct current because its magnitude is changing, but its direction is not getting reversed. So for anything, for any current to be called as an alternating current, the first thing that should happen is direction should change with respect to time. Means direction should get reversed. Where you call this as the positive cycle and you call this as the negative cycle. So basically, alternating currents are bidirectional, whereas direct currents are right. Whereas direct currents are unidirectional. Is that clear? Is this point clear? So basically, if I have to give the simplest definition possible for alternating current, you call it as bidirectional current. Means it has two directions associated with respect to time. Whereas when you talk about a current which is confined to one particular direction, irrespective of whether the magnitude is changing or not, you call that kind of a current as direct current. The clear, guys? Right? So now the next question is, what exactly are we going to discuss in this chapter? So if you revisit the second chapter, right, by the time we completed second chapter, it's the third chapter, right? Current electricity was third chapter. By the time we completed third chapter, we knew about two passive elements. What were they? Passive elements. Passive elements are those which consume current to work. What were they? Resistors and capacitors. Right? We knew only these two. But by the end of sixth chapter, we came across another OR device called as inductor. So now we know resistor, capacitor, and inductor, right? So what we will do is, instead of connecting a direct current to that particular device, we will try to connect an alternating source to all these devices and try to understand what kind of outputs they generate. Is it clear? So what are we going to do? We will take all the passive elements like resistor, capacitor, and inductor and connect them across the alternating source and find out what is the value of current that is getting generated due to the given input. Okay. So there are two things that we will discuss about. One is called as the input value, which is obviously the voltage, which is given by the value E is equal to E naught sine omega t. So for all the devices that we are going to discuss, this is the common input. Okay. Whereas when you have to define a different kind of, whereas when you want to define an output, output is defined in the form of current, right? So we will try to find out for the given instantaneous EMF, what would be the instantaneous current getting generated across each device. Okay. But before that, we need to discuss about certain important terms. One is called as the amplitude of the EMF. What is amplitude? From that expression itself, you can see E naught, the maximum value attained by the EMF during the whole cycle is what we call it as amplitude. Then what is time period? Time period is the time taken by the alternating current to complete one complete oscillation. So that is one positive cycle and a negative cycle put together is, so the time taken to complete a positive and a negative cycle is what we call it as one time period. So when you talk about time period, you can also define what is frequency. What is frequency? It is a reciprocal of time period. Yeah, the number of times a wave oscillates, or the number of times a wave completes an oscillation in 1 second is what we call it as frequency, right? So having said that these values exist, now what we are going to discuss is, for the given alternating current or alternating EMF, we will try to define, I repeat, we will try to define what is called as the average value of AC over a complete cycle and something called as RMS value over a complete cycle. Okay, so write down the heading as average value of AC over one complete cycle.
Sir,
Tell me.
sir, if only the magnitude changes, is it AC or DC?
Sorry?
If only the magnitude changes and not the direction, will it be alternating or direct?
Direct.
Okay, sir.
So write down the heading. Average value of AC over one complete cycle. Okay. So I would like to give you a disclaimer. Listen, this chapter is not easy. Okay. So I want you all to pay maximum attention possible and get your doubts clarified. Saria. So concentrate. So what is the heading? Average value of AC over a complete cycle. Right. Now see, we know that E is equal to E naught sine omega t. From this, so this is a value of instantaneous EMF. If suppose I want to write the value of instantaneous current, then how can I write it in the form? Can I write I is equal to I naught into sine omega t, where this I will call it as instantaneous current? Can I say? Now the point is, how do I find the average value of a function? Average value of a function over a given time period. So how do I find it? So So I suggest you write it along with me. Okay. So how do you find the average value of a function over a given time period? Now the point is, if I take the values like 1, 2, 3, 4, 5, and I ask you what is the average value of this, what will you tell? 1 plus 2 plus 3 plus 4 plus 5, the whole divided by 5. So that will give you a value. Is that right? No. So average value of function over a given. So this is applicable when you take for discrete value. Okay. When you calculate for discrete value. Whereas when you talk about a function, functions are basically continuous in nature. For continuous values, you cannot go with just adding the values. Rather, you need to go with the calculus. So how you do that is integral of 0 to capital T f of t dt, the whole divided by integral of 0 to capital T dt. So this is going to be the value. Integral of 0 to capital T f of t dt divided by integral of 0 to capital T dt. And this is how you find the average value of the function f of t. Is that clear? Is it clear, guys? Now, using the same logic, how do I write average value of a function? Okay. So, then how do I find the average value of I over a complete cycle? How do I do that? For that, I'll do something like this. Listen. Integral of 0 to capital T I dt divided by integral of 0 to t dt. Okay. In the place of f of t, I replaced it with I because I is also a function of time. So I can write it as integral of 0 to t. What is the value of I? I is I naught sine omega t dt, the whole divided by capital T. Because integral of 0 to capital T over dt is capital T only. I hope you understood the denominator. Am I clear? So, can I write this as I naught divided by t into integral of 0 to t sine omega t dt? Okay. Now, this will be equal to I naught divided by t into what is the integral of sine omega t dt? Integral of sine is minus cos divided by omega between 0 to capital T. So I naught divided by t into or omega t into minus cos omega into capital T plus cos 0. Sure. Keep writing. Done? There is. Done? So is there any doubt till this step?
Sir,
Tell me now.
sir,
Ah.
how the denominator came like minus cos omega t by omega?
The integral of sin x dx is minus cos x. Okay. Integral of sin 2x dx is equal to minus cos 2x divided by 2. Because whenever you differentiate the output of an integration, you should get back the question. Are you able to understand? For example, if I differentiate minus cos x, I'll get sin x. If I differentiate minus cos 2x divided by 2, I'll get sin 2x. If I don't write that 2 in the denominator, I'll not get it. How did you get that 2 in the denominator? The logic for it is derived using method called a substitution method, which we'll be learning in 7.2 in your math. Otherwise, you have to remember one thing. See, for example, there is something like chain rule, correct? D by dx of sin 2x is 2 cos 2x. Okay.
Yes, sir.
So, integration is called as antiderivative. So, when you're differentiating a function, this is called as a composition of function. When you're differentiating it, you get a chain rule. So, you get 2 cos 2x means that factor which is there inside the argument will get multiplied. Whereas when you're integrating, it will get divided. Okay, that is the simplest way to remember. Nitish, I hope I answered your question.
Yes, sir.
So minus cos omega t plus cos 0, correct? So this will be I naught divided by 2 pi by capital T into capital T minus cos of 2 pi by capital T into T plus cos 0. So this and this will get cancelled. This T and this T will get cancelled. I'll get I naught divided by 2 pi into minus cos 2 pi is 1 plus cos 0 is 1. Answer will be a 0. Omega's definition is 2 pi by theta because T is equal to how much? 2 pi into F. Correct? So F is equal to sorry. I made a mistake. F is equal to 1 by T. Is there any? So when I multiply with 2 pi on both the sides, I get 2 pi by capital T. So 2 pi into F is omega is equal to 2 pi by capital T, which implies T is equal to 2 pi by omega. Got it? So I just have an important point to tell you. Did you all understand the fact that when you try to calculate the average value of AC over a complete cycle, the answer comes out to be 0. So when the average value is coming out to be 0, is there anything that we can do with that current? Obviously, no. So that is why when you see, since the average value, when you're defining it over what? Which cycle did you define it? You defined it for a complete cycle. I repeat it. When you define the value of average current of AC over a complete cycle, you got the answer as 0. That is the reason why average current is not defined over a complete cycle. Average value is always defined over a half cycle. So when you try to calculate average value of AC over a half cycle, okay. Now I'm going to give you the equation and 5 minutes time for you to revise the previous derivation and look at it and solve it. It is exactly the same steps that you need to follow except the limits. So integral of I dt, no change in that. So look at the first step in the previous one, integral of I dt only divided by integral of dt. Correct? What were the limits we took in the previous case? 0 to capital T. Now what are we supposed to do for half cycle? You will take it as T by 2. Half cycle, half of time period. So 0 to T by 2. Here also you will take it as 0 to T by 2. Where in the place of I, you will write it as I naught sine omega t dt divided by integral of 0 to t by 2 dt is how much? T by 2. Accepted. Right. So this will become 2 divided by t into integral of 0 to capital T I naught. I can actually take that I naught also outside. So 2 I naught divided by t into sine omega t dt. Observe till this step. If there is any doubt, let me know.
Sir, the upper limit should be 2 by 2, right?
Because integral of 0 to capital T by 2 dt term. What is integral of dt? T. So this is between 0 to t by 2. So upper limit t by 2 minus lower limit is 0. Another t. Breathe. Okay. Apart from that, any other doubt? Tell me now.
Sir, shouldn't the upper limit be t by 2?
Oh, sorry. Now is it fine?
Yes, sir.
Okay. Now I'm giving you 2 minutes time. I want you to solve and tell me what is the final value. You have to follow exactly the same steps which you did in the previous case. Okay. One hint is in the place of omega, substitute it as 2 pi by t. What is the answer? Still breaking heads. Minus a varadra. After you apply the limits, minus a. You just copy those steps. Sir. You will not get 0. I never told you will get 0. If you are getting 0, the half cycle. You will get a non-zero value. And the non-zero value I want to know. Complete cycle another limit portal. I asked you to integrate and tell me what is the output of this. Is that what I asked? That's it. What is the answer? Anybody who is online, did you get the answer? Cos by euro. You will get minus cos by. Cos by is how much? Minus 1. I naught by pi or 2 I naught by pi?
2 I naught by pi.
You will get 2 I naught by pi. Right? I hope most of you got it. So let me do it for the sake of people who didn't get it. So minus cos omega t divided by omega. Correct? Between 0 to t by 2. Seriya? So 2 I naught divided by t, I can take that omega outside. Minus cos of omega into t by 2. Minus of minus 0. That is plus cos 0. So 2 I naught divided by omega, I can write it as 2 pi by t into minus cos of 2 pi by t into t by 2 plus cos 0 is 1. This and this will get cancelled. This and this will get cancelled. So t and t are gone. 2 and 2 are also gone. So I naught divided by pi multiplied with 2. So we will get 2 I naught divided by pi. And if you find the value of 2 by pi, right, it comes out to be 0.637 times I naught. So what are you getting? You are getting a number which is exactly equal to 0.637 times I naught, which we call it as the average value of AC over what? Over a half cycle. Okay. So going forward, whenever I ask you what is the average value of AC, what is the first point that will come to your mind? It is always measured for half a cycle, not full cycle. And that value for half cycle is going to be 0.637 times I naught. Remember that it has a significance. I'll tell you what it means. Is that clear? Right? So shall we move on to the next one? So you calculated average value, right? Now you need to calculate another value. Tell me.
So the previous value, 2 I naught upon pi, is that the amplitude?
I naught is amplitude. 2 divided by pi is the multiplication factor. That's it. I naught is amplitude.
Okay, sir.
Okay, in physics, wherever you put the subscript 0 or not, that value will generally be amplitude. Seriya? Now the next question is about finding another value called RMS or virtual or effective value of AC. I repeat it. It's called RMS or virtual or effective. All the three mean the same. You have to tell me what is RMS. You have to tell me what is RMS. You would have learned in kinetic theory of gases.
Root mean square.
It's called root mean square. Okay, here you are using the word root, right? You're using the word root. What root does it represent? Is it a square root, cube root, fourth root? It's the square root, and correct answer. It is square root. So, like how you found the average value, right? Now we are going to find the square root of mean. Mean means average. So square root of the square of the average. So that is the meaning of root mean square. Correct? Square root of square of the mean. Mean means average. So square IRMS, I'll write it like this. Square root of integral of 0 to capital T. You write it as I square dt divided by integral of 0 to capital T dt. So RMS value is calculated over a complete cycle only, whereas average value is calculated only for a half cycle. Is this point clear? So this is what is called as RMS value. Right? Square of mean term. You're squaring and then taking the average of it. Is that right? Now, I will take only the numerator. Integral of 0 to capital T, I square dt is equal to integral of 0 to dt, I naught sine omega t square times dt. I considered only the numerator. Denominator, I'll take it at the end. Okay, let me call this as equation number 1 by the way. So from equation 1, I've taken only the numerator. So what will I get? I naught square into integral of 0 to t sine square omega t dt. Can I write it in this way? Is there any doubt, guys? Can I write it in this way or not? Yes, can I? Yes. The next point is I naught square into, like how you have differentiation for sine square omega t, you don't have a direct differentiation for, integration for sine square omega t. So you need to do some manipulations to arrive at that particular step. So how you do that is integral of 0 to t sine square omega t, you can write it as 1 minus cos 2 omega t divided by 2 times d. Or you write it as 1 minus cos 2 theta divided by. So it will be I naught square by 2 into integral of 0 to t. This will be dt divided by 2 minus integral of 0 to t cos 2 omega t divided by 2 times d. Is this clear? Am I clear till this step? So I suggest you guys to copy it till here.
Sir, can you scroll down?
1 minute. The people are copying. Done. Did you copy this? Okay. So I naught square by 2 into integral of 0 to capital T dt by 2 is how much? It is t by 2 minus 1 by 2 into integral of 0 to t cos 2 omega t dt. Okay. Listen. This 0 to t cos 2 omega t dt is there, right? This part alone I want you to do and tell me what is the answer. I'll give you a hint. Integral of cos 2 omega t is sin 2 omega t divided by, correct, sin 2 omega t divided by 2 omega. Having this point in mind, I want you to find out and tell me what is the answer for this part. 2 minutes time.
So is it 0?
Sorry, some testing is going on inside. So is it
Sir,
done?
is it 0?
Yes, that is right. How many of you got 0? The answer is yeah, I've already given you the value. Sin 2, it is 0. Okay. So then you will get I naught square into capital T divided by 2. Is it clear? So I naught, so this is the value of numerator. Then IRMS will be equal to what? Square root of
So shouldn't it be I naught square capital T divided by 4?
yeah, 4. So it will be I naught square T divided by 4 divided by capital T.
Sir, but isn't it 2, sir? Should be 2, right?
No, it is 4 only. No, this 2 and this 2 will get multiplied.
Sir, actually, you've written it twice, I guess, from the previous time.
Oh, I did it twice. That's right. Hey, 1 minute. There is a mistake. 1 minute. I took this 2 twice. So this 2 should have come out. Then this would have been. Then here there is no 2. Here the answer would have been I naught square t divided by 2. And this will also be 2. This t and t will get cancelled. You will get the answer as I naught divided by root 2. And the value of IRMS is given as 1 by root 2 times I naught, or this is also equal to 0.707 times I naught. Are you able to understand? So when you calculated the RMS value of AC, you got the value as 0.637 times I naught. And when you calculated the average value, you got it as 0.637 times I naught. And when you calculated the RMS value, you got 0.707 times I naught. Right? So you calculated the average value and instantaneous average value and RMS value for what current? Alternating current. So when you say the current is alternating in nature, aren't we supposed to expect the output also to be changing with respect to time? Whereas when you see the average value, right, you took I naught, right? So I naught, is it a constant value or a varying value? When I take a graph, so listen to my question carefully. When I take the graph in this way, then this is going to be I naught. Then this is also going to be I naught. So what is the value of I naught? I naught is the maximum value attained by the current in that particular value. So it will attain the same value in the positive cycle and in the negative cycle. So I naught is a constant value. What is changing? I is changing. Direction, okay. I is changing. I is instantaneous value. So average value, what did we get? I average, we got it as 0.637 times I naught. And I RMS, we got it as 0.707 times I naught. Listen to this carefully. So a factor, a number multiplied with a constant value, can I call it as a constant? Similarly, 0.707 times I naught. A number multiplied with another constant is also a constant. So when you try to find the average value or RMS value of time varying current, you are actually getting a constant value. So what is it?
Sir?
Yeah, please tell me.
So from where did we get the 0.637 I naught?
2 by pi. In average
So, but that
value,
is for half cycle, right?
Half cycle only average value. So average value is always calculated over half cycle. That is what I told you in the previous section. I wanted to mention why average value is calculated only for a half cycle, because for a full cycle average value is 0. No, that is the reason we calculated it for half cycle. So the conclusion is average value is calculated only for half cycle and the RMS value is calculated for full cycle. But the important point I want you all to concentrate is on finding the average value and RMS value of a time varying current. You are getting a constant value, means you are getting a DC value, means the average value or RMS value of AC has something to do with direct current. For that, let's try to take an example and understand. Suppose I give you a 12-watt bulb across which you connected a 12-volt DC battery. Okay. Across the same 12-volt bulb, you connect an AC source like this. So AC source is basically represented with a circle and something like this, because alternating currents are mathematically written in the form of sinusoidal waves. So what do you mean by sinusoidal? You either write it in terms of sine or cos. Sine waves and cos waves are called as sinusoidal waves. Okay. So the same 12, now try to understand the story here. Listen to this carefully. Listen to this carefully. So you have a 12-watt bulb in your hand, which is connected to a 12-volt battery. So this will give a certain amount of brightness to that bulb. So when I say brightness, it is some amount of intensity that is associated with it. Now, if you take the same 12-watt bulb and connect it across an AC source, then what value of AC should be equal to this DC is what the question is. For example, If I take the AC source to be E is equal to E naught sine omega t, if I connect the alternating source directly, then what will happen is there will be a continuous variation in the brightness and darkness of the bulb that is glowing. It will start blinking, which will actually not be comfortable for us. So when you're trying to define the particular EMF value that you need to give to the electrical devices, you need to fix a value for it. Okay. Then what will happen is, if I make this AC source, which is having 0.637 times I naught, then the bulb will glow with certain amount of intensity. If I connect it with 0.707 times I naught, it will glow with certain amount of intensity. So not I naught, it is E naught. Okay. Now what I'm trying to tell you here is, if from the instantaneous values equation, if I'm able to find the average value of that AC and RMS value of that AC, you can see that the value of RMS value, that the RMS value of AC, that is 0.707 times E naught, will exactly be equal to that value of DC that you're connecting, so that the bulb, the same 12-watt bulb, whether you connect it to a DC source of 12 volt or an AC source of whose RMS value is 12 volt, will have the same amount of brightness. From this, what we can conclude is, you know what is the value of current that we are, what is the value of voltage we are getting at our home? So it is somewhere around 220 to 240. That's what we see. Okay. So on an average, you can take it as 230 volt. So this 230 volt that we are receiving at our home is actually not the peak value of AC, rather it is the RMS value of AC. The meaning of it is, this fan which is revolving with the speed will also revolve with the same speed if I am able to replace this AC source with a DC source whose battery value should be, whose EMF should be 230 volt. That is the meaning of it. So RMS value of AC or average value of AC are those values of equivalent DCs that should be replaced so that the devices perform certain functionalities just like how they did it before. Are you able to understand? So I repeat my point again. The tube light or this TV, all these are getting operated at 230 volt only. So if I want these devices to work exactly the same way and I want to replace the AC with DC, then I need to replace with what value? I need to replace a DC battery with an EMF of 230 volt. And the 230 volt, where did we get the idea from? Because it is the RMS value of AC based on which all these devices are working. So many people think that that is a peak value. It is not the peak value. It is the RMS value. So RMS value, RMS value is that value of DC, okay, which will make the devices give you the same amount of brightness or the same functionalities as done by your DC source. Is that clear? Did you understand the significance of it? Did you understand why we are studying these things? Right? So one point I would like to mention here is, E RMS is equal to E naught divided by root 2. Accepted? See, I RMS is I naught by root 2, means E RMS will also be E naught by root 2 because same mathematical equation. Now, E RMS value that we are using at our home is how much? 230 volt. Then what will be the peak value? It will be 230 times root 2, which will approximately come out as 311 volt. Means the peak value of AC that we are getting at our home has a value of 311 volts. So if you want me to write the mathematical equation for it, I will write it as E is equal to 311 sine omega t. So this is the value of instantaneous current that is being supplied to our houses. Is the point clear? Right? So this is all about the average value of AC and the RMS value of AC. So we can stop with this, make a note of this point, and in next class we will discuss about what will happen when you connect the devices across different kinds of passive elements. Is it clear? Yeah. So those who are online, I hope you are clear.
So this is the instantaneous voltage, right?
Instantaneous voltage that we are receiving at our home.
Okay.
Sir,
Right, instantaneously you need to write it as function of sine. Tell me.
Sir, you told that this significance is that if we replace the AC with DC, it should be the point
It should be
that
the
much
RMS.
time. It should be RMS or average value. Which one?
RMS.
Okay. Sir.
So make a note of it.
Sir, can you scroll up where you cancel the two?
Done. Guys, we can wind up.
Thank you.